10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
T plus 30 seconds and Electron has left the pad at Rocket Lab Launch Complex 1 in New Zealand, carrying the Astro-scale Adras-J payload. In a few moments, Electron will curb its engine power just a little to pass safely through the launch milestone known as Max-Q, or maximum aerodynamic pressure. This is the moment during ascent when Electron will experience the most amount of stress on its way to space.
Cleared Max Q.
And Electron is clear through Max Q. All is looking nominal at T plus 1 minute and 24 seconds into the mission, with Electron cruising along at speeds of over 2,600 kilometres an hour and now at 23 kilometres in altitude. If you've joined us in the past, you'll be very familiar with the next 3 events happening back to back.
First will be the shutdown of the first stage's 9 Rutherford engines in preparation for when the first and second stages separate from each other, and then the engine will start up on Electron's second stage. Those actions are called out as MECO, which stands for main engine cutoff, followed by stage separation and then stage 2 ignition. We are expecting to hear those calls from Mission Control in just a few seconds.
AOS channels.
Entered burnout detect mode.
MECO confirmed.
Stage separation successful.
Stage 2 ignition confirmed.
And that's MECO confirmed, stage separation and second stage ignition, all seen from onboard cameras on Electron. From the second stage, we're now getting a live view of the space-optimised Rutherford engine that's powering the mission to orbit. Up next is fairing separation in just a few seconds. We'll likely see those 2 fairing halves fall away after the split, so watch out for that on your screen.
Fairing jettison succeeded.
That was the 2 fairing halves successfully deployed there, introducing Astro-scale's payload to space. The mission is moving along in this second phase of the journey at more than 8,600 kilometres an hour now, at an altitude of 127 kilometres.
The burn on this Rutherford engine should continue for another 4.5 minutes or so before we get to the final stage separation between the second stage and the kick stage with Astro-scale's payload. For that event, we should see the Rutherford engine on the second stage turn cold before the stages separate. But before we get to that nozzle on your screen there will stay bright and hot as Electron continues on its trajectory to orbital insertion.
Electron has hit the 9,800 kilometre an hour mark on its way to orbit with Astro-scale. We're 4 minutes and 14 seconds into the mission now, having already completed liftoff, clearance through Max Q, main engine cutoff, stage separation and second stage ignition. We have around 5 minutes left in this second stage engine burn to take the mission all the way to its target perigee of 522 kilometres. The perigee is the lowest point in an elliptical orbit, and from there the kick stage will coast around to the apogee of 600 kilometres. The kick stage will then ignite for final payload deployment of Adras-J.
You can see from the telemetry data on your screen that Electron is now moving very quickly towards orbit. The second stage is on a nominal trajectory with the Astroscale payload, with everything looking great so far on this mission. At T+9 minutes is when that second stage engine is expected to end its burn and shut down for the final stage separation. And before we get to that, we'll first need to perform an action unique to the Electron rocket called a battery hot swap.
This happens only on the second stage of the vehicle, about halfway through the Rutherford engine burn time, when the first set of batteries that have been powering the engine's electric pumps are close to being empty. The battery hot swap replaces that first set with a new battery pack to power the engine the rest of the way. We're coming up on that milestone now, which should be coming across the net shortly.
Holding nominal, approaching hot swap in roughly 30 seconds.
Throttling down.
Hot swap successful.
Guidance is nominal 100.
We saw a flash of it there as it dropped away. The battery hot swap is now complete. Another major milestone with a green tick. Soon it will be shut down for SECO, or second engine cutoff. This is the same process the rocket went through for main engine cutoff on the first stage, before the stage separation earlier in the mission. The second stage engine will throttle down before shutting off completely, ahead of the kick stage separating with the Astroscale payload, so the mission can continue on to payload deployment. SECO is scheduled for T+9 minutes 5 seconds, which we are coming up to shortly.
Stage 2 propulsion, still holding nominal.
You'll notice on the right side of your screen the fuel and oxidizer levels of the second stage engine. With just 22% of kerosene and 22% of liquid oxygen remaining, that puts us with just over a minute until the end of the second stage engine burn. With Electron moving at 20,000 kilometres an hour now, we're coming up quickly on orbital velocity. All right, 2 more milestones this side of the coast phase of launch. SECO, or second engine cutoff first, followed by kick stage separation. The vacuum-optimised Rutherford engine will throttle down ahead of shutoff, and then the kick stage will separate from stage 2. Let's check back in now with Mission Control and listen to those calls.
Entered burnout detect mode.
Terminal guidance, 18 seconds remaining.
SECO confirmed.
Stage 3 separation confirmed. And nominal transfer orbit achieved.
Great news there from Mission Control, and as you saw on your screen as that engine nozzle cooled down, we have had a successful second stage shutdown and separation of the kick stage. Astroscale's payload will now enter a coast phase as it completes its first lap of the Earth, with the kick stage on an elliptical trajectory. Once the dots connect is when the kick stage's Curie engine will ignite, placing the payload in its final orbit.
Once Adras-J has been deployed, the satellite will use ground observation data to determine exactly where its target H-2A spent rocket is, so the satellite can cautiously approach and use its own onboard rendezvous sensors to get closer. The spacecraft's job on this mission is to understand what condition the H-2A rocket is in. Is it tumbling, and if so, how quickly? What is its exact location, and can it be safely latched onto? This is called the Rendezvous and Proximity Operations, or RPO, and a successful demonstration of RPO on this mission could open up a world of on-orbit servicing possibilities, including active removal of space debris.
For now, the kick stage continues on its first orbit of Earth with Astroscale. We'll be back here on the webcast in about 50 minutes or so to take you through the final moments and payload deployment. Set to take place at T+1 hour, 4 minutes and 30 seconds. See you here soon.